First off, we are going to look at area of composite figures. So what you're going to want to make sure you have handy is your formula chart, okay? So if you want to get your formula chart out while we are starting to fill this out, all of your formulas that we're going to need are right there. All right, so composite figures. So what a composite figure is it is a figure that can be divided into regions that are basic plane figures, okay? So you're going to take something that looks weird and you're going to divide it into triangles, rectangles, circles, or whatever is a shape you actually recognize. Because if you look at your formula chart, there are formulas on there for figures. Now, obviously, we don't have a formula for a figure that looks like this, but we're going to be able to divide it up into figures we do have formulas for. So to find the area of a composite figure, you divide the figure up into regions, find the area of each one, and then you're going to find the sum of all of them together. So if there's 3 figures, then you add 3 areas. If there's 2 figures, you add 2 areas, so on. So this first figure, we have a rectangle and a trapezoid. So what we're going to do is we're going to use the information here to find the area of the rectangle first. So the area of the rectangle is base times height. Well, the base of this rectangle is 23, and the height of this rectangle is 12. So 23 times 12 is 276. Now we're going to find the area of the trapezoid. And the formula for a trapezoid is 1/2 the height, and then add your bases together. So this base is 23, this base is 15. Your height is going to be right in here, okay? Even if they don't draw it, it still exists. So you may have to draw it yourself. Now, if you notice over here, it says that from here all the way to here, so top to bottom is 18. But we know this part is 12. So if all of it from top to bottom is 18 and the top part is 12, that makes this part 6, because 12 and 6 add up to 18. So now I have 1/2 the height, which is 6, times 15 plus 23. So 1/2 of 6 is 3, and this is 38. So 3 times 38 is 114. So your total area is 276 plus 114, which is 390, and that is centimeters squared. So that is how you have to go through and do composite figures. In the next figure, there are 2 semicircles. 2 semicircles, when you put them together, will make a whole circle. So we're going to find the area of a circle. And then this figure here, with all the little arrows on it, that's your parallelogram. The area of a parallelogram is base times height. So pi r squared. Well, since this is the center, my radius is 6, so this is 36 pi. Now for your parallelogram, your base is one side that is perpendicular to the height. So this is your height, this is your base, because it's also perpendicular to that. Okay, so if this is 6, here, let me erase that because that looks like a 6. If this part is 6, then the other radius is 6, so the whole thing is 12. So your base is 12, your height is 5, that would be 60. So the area of the entire composite figure is 36 pi plus 60. So 36 pi plus 60. That is 173.1 inches squared. All right, in the next one, we have 3 things, okay? There is a semicircle, there is a rectangle, and then we have a triangle. Now, if things are missing, then you have to use the information that's given to find what's missing. So we know for a fact that from top to bottom is 26. So we're going to need to find this. We're going to need to find this. We need the base of the triangle. We know this is 9 because this is 9 because a rectangle, opposite sides are congruent, which means this radius right here is also 9, and so is this radius. So if top to bottom is 26, and this piece right here is 9, that makes this piece 17. So if the whole thing is 17 and the top is 7, that makes this piece 10. So you got 7, 10, and 19, which will add up to 26. So you have to use what's given. So always remember, if you know the whole thing and then you know part, you're always going to have to subtract, okay? So let's find the area of the triangle. So 1/2 base times height. The base is 9. The height is 10. So 10 times 9 is 90. Half of 90 is 45. And then the rectangle is base times height. So that's going to be 9 times 17. So that's 153. And then the semicircle is 1/2 pi r squared. So 1/2 pi, 9 squared. So type that in your calculator, 0.5 pi times 9 squared. And that is 127.23. And then you're just going to add all 3 of those together. So 45 plus 153 plus 127.23. We get that our total area is 325.23 feet squared. So we're just basically taking information that we already know how to do, because we already know how to find the area of a rectangle. We already know how to find the area of a square. We already know how to find the area of a circle. We already know these things. So we're just going to add them all together. So this next figure is a snow cone. Actually, it's a triangle and a semicircle, right? So here is the base of my triangle, and I'm going to need to draw the height. So if my base is 16, then this piece is 8. So to get the height, I'm going to have to do Pythagorean Theorem. So 17 squared minus 8 squared equals 15. So my height is 15. So the area of a triangle is 1/2 base times height. So 1/2 16 times 15. So that is 120. So the area of the triangle is 120. The area of the semicircle is 1/2 pi r squared. 1/2 pi, 8 squared. So type that all in your calculator, and you get 100.53. Add your 2 areas together. So 120 plus 100.53, your total area is 220.53 meters squared. So make sure that you are looking for right triangles so that you can do Pythagorean Theorem. It's super important that you recognize that right triangles in 2 sides, Pythagorean Theorem. So maybe make a note so you don't forget to decide. If you know two sides of a right triangle, use a squared plus b squared equals c squared to find the third side. See if I can get all that in there. Last one, and then we're going to talk about shaded regions, okay? So the last one here, now we have a square, and then we have a trapezoid, and then we have a triangle. So I'm going to add 3 areas together this time. So looking at the information that's given, I know that I need the base of this triangle, and they gave me the height. And I see here that this is a right angle, which makes that a right angle. And I know the hypotenuse of that little tiny pink right triangle. So I'm going to do Pythagorean Theorem to find this piece right here, because once I find it, I'll know the base of the triangle, which means I also know the side of my square. So 12 squared minus 9.6 squared, take the square root, will give us x, which is that little tiny piece right there. So 12 squared minus 9.6 squared, which is 7.2. So if this piece is 7.2, then the whole thing, so this is 7.2 also, so this is 14.4. So the area of the square is going to be 14.4 squared. So the area of the square is 207.36. Now the area of the triangle is 1/2 base times height. So 1/2 the base, which is 14.4, times the height, which is 9.6, because they were nice and gave it to me. So this is 69.12. Now the trapezoid. So that's this, which is 14.4. The base is 10. So area is 1/2 the height, which would be this number right here. So I know the whole thing from top to bottom is 25.4. So 25.4 minus, because remember this piece here is 14.4. So subtract, so 25.4 minus 14.4 is 11. So this part is 11. So from here to here is 14.4. From here down is 11. So 1/2 the height, and then add your bases together. 14.4 plus 10. So this is 5.5, so half of 11. And this is 24.4. So 5.5 times 24.4. So this is 134.2. So add your 3 areas together. And I'm getting, oh, I think I hit something wrong. 207.36 plus 69.12 plus 134.2. There we go. 410.68 meters squared. All right, so now we're going to talk about shaded regions, okay? So to find the area of a shaded region, you're going to find the entire figure, and then you're going to subtract the area that's not shaded. So basically, identify what 2 things you need to find, subtract one from the other, done. So here, and the way I always look at these is I'm like, okay, what's the figure on the outside? Figure on the outside here is a square. And I'm going to subtract a circle. I always think of this example as if I have a piece of paper and a hole punch and I punch holes in it, I'm subtracting space, I'm subtracting area. So the area of a square is side squared. So that's going to be 25 squared, which is 625. Minus the circle, pi r squared. So I need to know what the radius is. Okay, well, my diameter is 25, so all the way across is 25, so that makes your radius 12.5. So remember, diameter is 25, your radius will always be half. So 12.5 squared pi. So this is 490.87. So you subtract the 2, and you get 134.13 feet squared. And number 7, we have a rectangle and a triangle. So I'm going to find the area of the rectangle and subtract the triangle. So my rectangle is 14 times 25. So 14 times 25 is 350. Subtract the triangle, which is 1/2 base times height. So the base of this triangle is the same as the side, so 25. And the height of my triangle is 11. So that is going to be 137.5. When I subtract them, I get 212.5 centimeters squared.